I've been replaced by Math Cat. Seems actually Pepper. Hmm. He's our mascot for math class. He's your math mascot. Our mascot. Our math cat. Yeah. All right. That was a bad pun. Hey, so Math Cats. Normally, Math Cat is sitting right over there. But this morning, Math Cat found a ladybug on a record player. So I have two cats, Pepper, pictured here, and his brother Salt. Salt's probably going to show up in a later problem. So Mr. J's cat, Pepper, spotted a ladybug spinning on a record player. You can see it right there, larger than life. So Pepper, being a math cat, decided to count how many times the ladybug spins around, and he found out the ladybug does 16 spin cycles on the record player in 40 seconds. And we're going to do some math here. We go. Number one, what is the rotational speed? Measured in revolutions per minute. So revolution and rotation, two different words that for our purposes mean the same thing. Both of those refer to circles, cycles, spins, a trip around a circle. Okay, so let's take a look back at our notes. Rotational speed, how many times an object spins per unit time, rotates per unit time, revolves per unit time. So Pepper counted that. I know how many times that object spins per unit time. So in order to calculate the rotational speed, I'm going to take the 16 spins divided by the time, which was 40 seconds, and we'll divide. And if I want to change this word, I could totally change this word. I can use revolution instead, because the directions did ask me to use revolutions per minute, and revolutions means the same thing as spins or cycles, trips around the record player. That's way too long to write, so I'm going to stick with revolutions. Okay, so the other thing I noticed in the directions is it does ask me for revolutions per minute, and right now I got 16 revolutions every 40 seconds. I can divide, and that will give me a rotational speed, but not the one the directions asked me for. Let me erase this equal sign. Let's convert. I got seconds written down right now, but the directions ask me for minutes. I need to convert from seconds to minutes. So here's my conversion factor. I remember, I think, like 60 seconds in a minute. Obviously, just kidding. All right, so I want 60 seconds to go in the numerator so that the seconds in red, we're going to cancel those seconds in green, the numerator here, the denominator there. Losing letters. Seconds here, cancel with seconds there. Now I have set up problem correctly. I'm going to find my answer and drop it in that box right there. So I'll need to do 60 multiplied, I'm sorry, I said that in the wrong order, 16 multiplied by 60 and divided by 40. 16 times 60 and divide by 40. I can do that all at once on this calculator. Equals 24 revolutions per minute. I want to put the 24 up as part of that numerator, 24 revolutions on the top over 1 minute. I could totally do that. That's fine. I can leave just the units as a fraction, revolutions per minute. All right, what is the angular speed in radians per minute? Okay, so I remember I just found rotational speed in part one. This is my rotational speed, 24 revolutions per minute. And now I'm being asked for angular speed. This sounds like I need to convert my previous answer of rotational speed into angular speed. Let's go to the notes. So rotational speed in my notes page is in green. Right underneath that is where I found angular speed. If it wasn't labeled in the problem, I could identify them because my first answer was giving revolutions per minute, which here it's bullet point number 2. That's how I identify rotational speed, revolutions per minute. or some other unit of time. And angular speed is going to be measured in radians per time unit. So my conversion factor that is written down onto the notes page between those two headings, rotational speed and angular speed, is right here. Conversion factor between rotational and angular speeds, 2 pi radians and 1 rotation. And I can change the word rotation to be revolution or cycle or circle or spin or trip around the record player or whatever is going to fit the problem. But 2 pi radians and 1 rotation, and I may need to do the reciprocal with my conversion factor just to make sure that the units will cancel correctly. Okay, so I'm going to start with the 24 revolutions per minute. And then I'm going to get my conversion factor. So I know that I have revolutions on the top of the blue part already, so I know that I want revolutions to show up in the bottom of my conversion factor so that it will cancel appropriately. So 2 pi radians is going to go in the numerator, just abbreviate everything to 3 letters. Blue revolutions and red revolutions are going to cancel. Problem is now set up correctly. Answer box. So the units, let's look at the units first. What's left? On the top, I have radians, and on the bottom, I have minutes. Those are the only units left, and that does match the direction that asked me for radians per minute. Nice. And then I'm just going to do mental math. 24 times 2, that's going to be 48 pi radians per minute. We're going to leave pi as part of our answer. That is customary when we're dealing with angular speed. I don't know if you were like to describe how fast your car was going down the street, you're probably not going to describe the tires going like 48 pi radians per minute, just as an example, because nobody would have any idea what that is. But that is how we describe angular speed. Okay, well, that's too many questions at once. Number 3. The ladybug is sitting 23 centimeters out from the center of the record. All right, Math Cat, he also does measurement. He's measurement cat on his off days, Math Cat the rest of the time. So 23 centimeters out from the center of the record. What is the ladybug's linear speed? All right, well, there's a bunch of stuff going on right here. Let's go to the picture. There's my ladybug. This is a still shot, but if we had a video, the ladybug is going to go round and round and round and round, make a red blur, right? It's going to trace out a circle. It's like a little ladybug tracer. The radius of that circle from the center of the record player out to the ladybug, that's 23 centimeters. You can't read that because too scribbly, but that's the radius. The size of the radius is 23 centimeters. All right, we want to find the linear speed, and the directions are asking us for centimeters per minute. Okay, we have 2 options for how we can get to linear speed. One option is we can use the previous answer from number 2, our angular speed, 48 pi radians per minute. We can convert that to a linear speed. Or other option is we could back up all the way to number 1. We can take this rotational speed of 24 revolutions per minute, and we can convert that to linear speed. It doesn't matter which one we choose. You're going to get the same answer either way. It's just a matter of you can use a different conversion factor and a different starting point. So you can go ahead and we'll vote. You guys want to use the rotational speed or the angular speed? Sorry, that's ridiculous. Obviously, you can't vote on a video recording. So I'm just going to go with the one that we can see because we can see it. 48 pi radians per minute. I'm going to set that up, and then let's go back to our notes and figure out what is our conversion factor. So this is angular speed from problem number 2, and I need to convert angular to linear. Okay, so our notes page, we're going to scroll down here. Okay, so the blue one is angular speed. We're trying to find linear speed. That's the purple one. Written right in between those 2 headings on the notes page is the conversion factor we want. It's the length of the radius in quotation marks. That means we replace it with an actual number and the word radius. Replace anything in quotation marks, always. Okay, so the size of the radius is a number and the word radius. I have to change colors here. We'll use green this time. That's actually not green. All right, computer. We're going to use green this time. Nice. I like it when it listens to me. Okay, so we already established that 23 centimeters is, in fact, the radius. So I'm going to put the measurement, 23 centimeters, that's the top part, and the word radius, that's the bottom part of my conversion factor. I did not want to make my conversion factor the reciprocal because right now radians in purple and radians in green are going to cancel, leaving me the only units that are left here are centimeters on the top and minutes on the bottom, and that is actually what the directions have asked me for, centimeters per minute right there. Okay, so I'm going to multiply straight across the top, 48 pi times 23, and that will give me my final answer. For linear speed, would not make any sense to describe how fast your car is driving down the road as a linear speed to use pi, right? Your speedometer in your car doesn't have a pi on it, right? Oh, I'm going 20 pi miles per hour. Am I speeding? Who knows? All right, so we're not going to use the symbol pi in linear speed. We're going to multiply by the number pi. So 48 times pi times 23. I want that whole thing as like a decimal number. So 48 times I lives right here in the calculator. It's on my TI. You can see the little exponent button right there. I'm gonna have to hit shift. Pi is right above that. So here's my blue second. There's pi, and then times the size of the radius. That was 23 equals. Wow, that's a big number. 3,468. 3468.3. 3468.38 centimeters per minute. That's a fast ladybug. It's also a terrible 8. Nobody can read that. Let's see if we can make this 8 more 8-ish. Okay. 8. That's better. Last question. Number 4. Number 4. The ladybug counts the little pits in the record. There's the little bumps in the like a vinyl record. It's got little bumps, and the needle picks up the little bumps. Those are actually the sounds as the needle bounces up and down on those little pits in the record. That's how record players work. So the ladybug does some counting on its own. It says there's 7 pits per centimeter on the record. So if Pepper extended a claw, turned himself into a gramophone, like Stitch, that'd be awesome, obviously. But what rate do the pits pass by Pepper's claw in pits per minute? Okay, this, I circled the wrong word. I'm trying to circle rate. Rate implies some kind of speed, right? And the directions here tell us we're looking for pits per minute. So in this context, pits is measuring the distance. Right, we got all the on the record player. These little pits. They're spaced out, uniform rate of 7 pits per centimeter. Okay, we're using it as now. We've kind of changed pits into a measurement of distance. So what I'm asked for, at what rate do the pits pass by Pepper's claw in pits per minute? That's also a linear speed. I just found a linear speed in number 3, and then question 4. I'm going to find a different set of units, still for linear speed. So I do not need a conversion factor out of my notes. I can take this previous linear speed of 3468.3 centimeters per minute and convert that from one type of linear speed to another type of linear speed by using the conversion factor that is described in the problem right here. It's 7 pits per centimeter. This is just straight unit conversion. 3468.3 centimeters per minute. And then I'm going to use my conversion factor, 7 pits per centimeter. If I set up my conversions in this way, I'll have centimeters in the numerator in red and centimeters in the denominator in blue. Centimeters will cancel. The only units that remain in this problem are pits on the top and minutes on the bottom, which is what I was asked for. So let's multiply. That previous number we had still should be in my calculator. Just multiply that by 7 times 7 is a very large number, 24,278.2. 24,278.2. 24,278.2 bits per minute. But wait, I think there's more. Oh my gosh. In the real life actual movie, when Stitch counted the record player, it was not going at the numbers that we just did. So let's try this. Let's try this. The real life movie, actually, Stitch counted the edge of the record to be moving at 5,000 centimeters per minute. And as Lilo measured the record, she found the radius was 18 centimeters. What is the record's rotational speed in revolutions per minute? Oh my goodness. Okay. Well, I know where I'm ending. It tells me I'm trying to end at rotational speed measured in revolutions per minute. We could call it rotations per minute, same thing for our purposes. Okay, so I'm trying to end at rotational speed. And here's what I'm given. I'm given 5,000 centimeters per minute. Well, I know a centimeter is a measurement of length or distance, and a minute is time, and so centimeters per minute. Let's look at our notes. Centimeters per minute seems to me like that's going to be a linear speed, distance and time, centimeters and minutes. So I have a linear speed. I was given that, and I am asked to convert that into rotational speed. So remember, our notes page, top rotational speed, bottom linear speed. Roll this into a circle. Sorry. Oh my gosh, I can't do this. Whew. Oh, it's creasing. Blam. So we can make linear speed and rotational speed touch. Bloop, bloop. Top of the page, bottom of the page. And so the conversion factor, which is literally placed in between linear speed here in purple, and when we loop this, the green rotational speed is this conversion factor. To convert between linear speed and rotational speed, we need the word rotation, or the word revolution, or the word spin of the record player, and in quotation marks, the circumference. The quotation marks, that's the clue. I need to replace that word with an actual number for the circumference. We can calculate the circumference by doing 2 times pi times the radius. All right, let's take this 5,000 centimeters per minute that we just had identified earlier. That'll be our starting point. Make that 0 look like a 0. Okay, and then my conversion factor is going to be the size of the circumference and the word revolution. Right? And in my notes, it had the word revolution on the top, or rotation. I can change those. I'm going to write down revolution because the question asks me to give my answer in revolutions per minute. Revolutions and rotations basically interchangeable for our purposes. Okay, so my conversion factor, the denominator of this red conversion factor needs to be the actual circumference. So let's pretend this is my record player. Here's the center. Lilo measured the record to have a radius of 18 centimeters. So circumference 2 pi times 18, which, if I do some mental math, that's going to be 36 pi centimeters. And maybe I don't want to leave pi in there, but I can take care of that later. I can multiply the 36 times the pi now or later. Okay, so the green centimeters in the numerator and the red centimeters in the denominator, those are going to cancel each other. The only units that remain at this point are revolutions on the top and minutes on the bottom. That is what the directions asked me for. So I've matched what the directions asked. I got the right conversion factors. I got them in there correctly. Everything is good. So I just need to multiply. Well, I guess in this case, I actually divide 5,000 divided by 36 pi. 5,000 divide by, and so if I just type in 36 pi, this is not going to work. If I type it in like this, my calculator is going to do 5,000 divided by 36, and that's it. Take that answer and then multiply it by pi, and that's not what I want. I want the 36 pi all to be in the denominator, so I need to have, just here, I'll show you. Here's what it's going to do the first time. That's wrong. And then let's type it in here again the second time. The right number of zeros, divide by, I'm going to use parentheses this time, 36 pi. So the lack of parentheses, super common cause of errors. You can see we totally get different answers there. 44.2 is what I do want, and that 436 is what a lot of times people get. And they'll be like, I typed it in right. I don't know what the problem is. Well, yeah, calculators and parentheses. So 44.2. 44.2 revolutions per minute. Final answer. So thank you, Lilo and Stitch, for giving us an opportunity to do some important math.